Good afternoon, everyone. I hope you are doing well. So here is Miss Shina, and I'm a science teacher, and today I'll be with you for this lesson, inshallah. And I'm gonna start the lesson, but first of all, I need to check whether the number of the ones who joined the meeting is equal to the number of participants that exist in the list. So 40 students now in the meeting. And we have 15 students in the list, so only one is left. Till this one will come, I need to give you some extra information or general information. First of all, before starting the lesson, I need all of you have a notes because notebook or copybook, whatever you are naming, because we're gonna write names, we're gonna write the notes and comments on this note. Please, we need it, it's mandatory. Why? Because you need it while you are doing the exam preparation. Also for now, at the end of the lesson, I'm gonna do a recap and ask you the main questions that we studied and the main points that we learned from this lesson. So let's go ahead. The student who's left it now join it. Well, so let's start. For our topic for today is on acid and base. Is on what? Acid and base. It is on acid and base. So, what's that? The lemon. Why is it lemon? How does the lemon taste? The lemon tastes sour. So, what is the main reason behind this test? The main reason behind sourness or sour taste of the lemon is due to the acid that exists in the structure of this lemon. As what is due to the acid that exists within the structure of this lemon, which make it sour. And the other point, all the acids make things to be sticky while touching. So sour while tasting, also sticky while touching. This is a basic information about acid. An example is the lemon. Not only the lemon, we use the acids in the daily use like sulfuric acid, which is H2SO4, H2SO4. Later I'm gonna write chemical formula, but you don't need, not required from you, only the extra information. H2SO4, which is sulfuric acid, are exist in the car batteries, which make the cars run. Also, the other acids that vinegar and some acids are safe, not harmful for us, but others are harmful. Maybe can burn our skin, like what we have HCl hydrochloric acid is a strong acid and it's harmful. Next, we will go to what? We will go to the to that. Was it? So, yeah. What's the main purpose that exists with the soap? Is they are slippery while touching. What they are? They are slippery while touching. What they are? They are slippery while touching. Also, the other point that exists within the soap is when we add water, they make a foam. Why? Because they are a base. The main properties that exist within the base is what? They are slippery while touching. Also, they taste bitter. Why? They taste bitter. Why? Because due to the base that exists within them. But there's another name for the base that we use. It is called alkaline. Alkaline. What we call alkaline. Then let's go ahead. This was only the basic information about acid and base, but now we will dive into the deep of our topic. What we have acid. Acids are substance that taste sour. So why the acids are taste sour? We said that because they have the acid and make things sour. The next point, let me use that's better. That's better. Uh, for example, we have some acids like grapes or coffee or vinegar, orange, and their sourness is different. Why? Because in the structure of all acids, we have what? We have hydrogen. What we have? We have hydrogen. In the structure of all acids, what we have? We have hydrogen. Here in my slide, in the structure of all acids, we have hydrogen. So this hydrogen increase the acidity of the substance. What will do? It will increase the acidity of the substance. Look, if you write all that contain hydrogen ion that release when dissolved in the water. For example, if you put the lemon here, what will be released? Hydrogen. Why? Because in the structure of the lemon we have hydrogen. This is an example. Let me write a clear example. For example, we have HCl, which is the hydrochloric acid. When we put that under the process or on decay process, what will happen to it? It will separate to the hydrogen and chlor. To what? To the hydrogen and chlor. But the main properties, what we have, this hydrogen is positive ion. And this chlor is negative ion. Why is it? Negative ion. So when we put this acid inside the solution or dissolve it inside the solution, what will happen? The hydrogen ion will be increased. Why? Because the acids are releasing hydrogen ions to the solution. So when this hydrogen ion is released, the acidity of this solution will increase. What will happen? The acidity of the solution increase. This is the main reason that, for example, when we put lemon inside the water conduct electricity. Why? Because the rate of the ion is increased. When the ion is increased, the current will be transported. This is the main reason. Then the other point, the acids turn litmus paper red and pink. The acids turn litmus paper to red and pink. What do we mean by that? For example, we have a litmus paper. This paper uh, came out from lighting, which is what we can, the lighting came out from as a natural indicator. And this is a paper. When we put this litmus paper inside the acid solution, the paper will be turned to the red or pink color. Why? Because indicate to us this solution is acid. But this paper, this litmus paper is an indicator. So what's an indicator? Guys, what's an indicator? We'll write the definition of indicator here. We need, please write this definition, do not forget. Indicator is what we can say, the thing that show us whether things are acid or base, indicate the situation of the solutions. So what's indicator? Indicator is what is the thing that show us whether things are acid or base, or we can say is a substance that show us whether things are acid or base. That's all. Please write this note. Then let's go to the next point. What we have? We have a base. What we have? Base. This is what it's a base. Base, we can say something opposite to the acid. Why? Because it tastes bitter. We already said that all the base are test what they are testing bitter. Also, while touching, we feel slippery. So test while testing is bitter, and while touching, we feel slippery. Also, there's another name for the base. What we called alkaline. What we called alkaline. What we called alkaline. Then, an example for the base, for example, detergent, shampoo, baking soda. Um, but the most important point with all base is what? They have OH group. What they have? They have OH group, hydroxide group. What they have? They have OH group, hydroxide group. What they have? They have hydroxide group. This hydroxide group, okay, let's clean up. Great. Why it's stuck it here? I don't know. Let's fix it. Great. Then all of them are contain what? All the base contain hydroxide group OH. So while they dissolve it inside the container, what they release? They release this hydroxide OH, which is negative. They increase what? They increase negative ions. Another properties that exist within the base, they turn the litmus indicator, the color of the litmus indicator, to the blue. To which color? To the blue. So when we put or dip a litmus indicator to the solution, the color of the litmus paper, when turned to the blue, it indicates that the solution was base. So let's go ahead. That's all. So the other thing that we need to focus on it is what will happen if we combine it acid and base together. When acid and base are reacted together, what will happen? The reaction will be formed. What we call neutralization reaction. We call to this action neutralization reaction. What we call neutralization reaction. This is formed when the acid and base react together. Guys, why we call neutralization reaction? What's the main purpose we call the neutralization reaction? For example, um, this is the summer and you are feeling hot, you are going out to have a walk. But accidentally, for in misfortune, a honey bite you. This biting, what will happen? It's just like the honeybee injected an acid inside your skin. So the acidity in your skin will increase. What will happen? The acidity in your skin will increase. That's why the color will be turned to the red, will be swollen. This is the main reason. Why? Because the acidity in your skin is increased. But how we can solve that? What is the main or what is the best medicine? How this medication work? How it work? We will bring baking soda or other medicines that will be given by the doctor. This one will be the base added to the acid. But why we call neutral, high neutral? Because those substance or the acid and base, they will what? They will cancel the properties that exist within each other. Huh? That's why we call neutralization reaction. What we call neutralization reaction. For example, for example, guys, we need also the definition of neutralization reaction. Uh, right here, neutralization. We use board, inshallah, for the neutralization reaction when acid and base react together. They cancel each other's properties. Proper. This was about neutralization reaction. And example for then we will come to the other examples of the acid and base. But before going to the example, there's another thing that I would like to share it with you, which is a pH scale. What? We have a pH scale. This pH shows the rate of acidity and base of this substance. What will show the acidity and base of the substance. Why is it? Is a pH scale which show the acidity and base of the substance. pH scale is the scale which indicates briefly the acidity and basicity or alkalinity of the substance, which the range starts from 0 to 6 pH or hydrogen. Also, do you know there's another name for the pH scale? Do you know what's the name? Huh? We called also the power of hydrogen. What's the other name? Power of hydrogen. This is the other name for the pH scale. What we call power of hydrogen. Why we call the power of hydrogen? Because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all of it is the hydrogen numbers. So the hydrogen or indicate the hydrogen rate. Look, uh, if it is from 0 to 6, it's acid. Otherwise, from 8 to 9 is base. And here, 6 is a weak acid, but 0 is a strong acid. For example, 6 is coffee like that, but 0 is, I think, HCl hydrochloric acid, which exists in our stomach. Also, 8 is a weak base, but 14 is the strong. What we call this the strong base. But guys, even this pH scale is not accurate. Why? Because sometimes the colors are confusing. Maybe the color is only turned to the orange. We confuse whether it's 2 or 3 or 0. But for better, when we have better result and a more accurate result, what we use a pH meter. What we use a pH meter. This is a pH meter. Why is it a pH meter? And it's any electronic equipment which give us the result accurately. That was all about our lesson of today. Please, if anyone have any question, um, anything else, and any information, anything is still ambiguous, not clear for you, I'm gonna explain more. And thanks for your participation. Have a good day.